course,
Continuando.
acceleration. Now, acceleration is about change in speed, change in motion. So clearly this is going to have something to do with the nature of space and time. And this is difficult because we have a really strong common sense view of what space and time actually are. And it's very hard for us to get rid of our common sense point of view and to think of it as just an arbitrary mathematical construct. So now to do this, let's play a little game here. Let's imagine, Brian, that I'm actually not a human, but I'm an artificial intelligence. I'm a computer in a box. I have no eyes, no ears, and you're just typing messages to me. And I want to know what this strange thing called space is that you humans keep talking about. How would you explain what space is to me as an artificial intelligence?
Okay, well, that's going to be a challenge. So I think we think of space as being a place that things happen. I think that's sort of
what is a place? What is a place?
A place. What is a place? A place has size and distance from us.
And what is the size and distance you are talking about?
So size and distance. So I measure size and distance by how far light travels in a certain moment of time.
What is this far you're talking about? The whole trouble is that it's very circular. We tend to use spaces where things are in different places. But what is a place? It's all very circular reasoning. I mean, can we think of any way we can explain it that doesn't involve a sort of circular reason in terms of other words that also imply that we know what space is? It's a hard one.
Well, I think you end up having to just write down a few axioms as we do in mathematics, and then we can use the language of mathematics maybe to describe what space is.
Well, let's imagine another thought experiment that space doesn't actually exist. We don't actually exist. We are just a simulation in God's supercomputer down in God's basement somewhere, a bit like the movie The Matrix. So let's imagine that God has a very big supercomputer and it has one memory register for every atom in the universe.
Okay, that's a lot of memory registers.
Yes, God makes pretty good computers.
Okay, good.
And each memory register records particle and three numbers, X, Y, and Z, the coordinates in three-dimensional space. So, for example, the first particle in the register, there's no actual fifth particle, just a set of numbers. It might be this atom on my nose over here. And that's got coordinates, let's define that as 0, 0, 0. And you go down, the next atom in the register might be, let's say, a neutron in a neutron star in Alpha Centauri or other end of the universe somewhere. And then the third particle might be even further away, and the fourth one might be one of the ones in your hair.
Yep. So we're going to put them in different memory registers. So presumably,
código binário, né?
The one that's right next to that first one, 0, 0, 0, and I'm going to put the atom right next to it. It's going to have a number pretty close to 0, 0, 0. It'll be like 27, 32, 45.
Yes. So what it means is, let's say my nose exploded for some reason. There's a radioactive element and it decayed.
Yep.
Which other atoms will be affected? One which has a coordinate of 4 million probably won't be affected. One with a coordinate of 0.01, it might. So what you could imagine is you have all these different memory registers, and then we do a time step, and we see, well, that one exploded, and then we go all the way to the register and see, it might take God months to do this, and find out every other one which has similar coordinates. So there has to be some measure for two sets of numbers. Let's say 111 and 113. Are they close or are they far apart? There has to be some way of comparing these two sets of numbers to work out proximity, and therefore see if an event that hits one of them hits another one.
You could literally calculate the distance between those three registers.
Yes, so what you need is three numbers defined in three dimensions, and you need some way, given the two sets of three numbers, to work out whether they're close or far apart, some measure of how much things affect each other.
Okay, so that sounds like a way of mathematics essentially describing space, a set of numbers, and we could think of it as a memory. I could imagine how that might work. And of course, we had that concept of time as well, we're going to have to eventually deal with as well.
Yes. So, I mean, it could be that is our universe. It actually is no space. It's just a register in a computer. How can we even tell? I think I see you, but that's because photons in one coordinate have photons in another coordinate and then interact with a memory register. The neurons in my brain fire in some sequences, but they could be quite different parts of this. So it could be this have similar numbers.
Okay, so you're saying we could be inside the matrix.
Indeed.
Okay, well, good enough for me. It's got me fooled.